Hello again to another video. Today I'll be using some voltage regulators I bought online. They are S&D parts to repair a power supply for my breadboard, which I had destroyed in the past. This is the power supply. You can see it's a Chinese brand. It's written here YwRobot, it says, and it has some jumper junctions where you can choose which kind of voltage you want. You can decide between 5 volts and 3.3 volts. And at this exact place there are 2 voltage regulators mounted here, and they're used to transform the voltage down. And what I did is I used this DC thing to power the device, and it worked okay until I was at my parents' place and I didn't have my usual DC plug. So I put in a plug with 1 ampere power supply, and this thing only handles 700 milliamps. So it blew out the voltage regulator for the 3.3 volt regulation. I'm not sure if the other one is damaged, but I'll just desolder the 3 volt voltage regulator and solder another one on it, and then I'll check if the board is okay again, or if it's not, I'll see what I can do. There are not many parts on this board. There's the diode here, the capacitor here, some, I don't know if those are LEDs, I think they might be, or they should, no, they are probably resistors. Yeah, so there is not a lot that could have gone awry, so it's probably just the 3.3 volt voltage regulator. If the 5 volt regulator is also destroyed, I can also desolder and replace it, because I have 3 and I have 10 of the 3 volt type and 10 of the 5 volt type, so no problem here. So as you can see, it's the same type. It is the, we see the AMS 1117 type, and this one's also the AMS 1117, but the second number is slightly different, but I don't think it's a problem. It says 3.3 volt on both, and this one has 0860, and this is H431TE, but I don't think it means anything. It's probably some manufacturer sign or something. So let's get to it. So now I'm sitting at my soldering station. First things first, I have to put on my safety goggles. So now that's that out of the way, I will mount this thing, or first I will power on the soldering station. And this is really bad because it doesn't have any markings where what temperature is at, but I know the lowest point is 150 and the highest point is 450, and I have 5 segments. So at the beginning of this year there should be about 350 degrees. I know it's not exact because it's somewhere between 300, I don't know, whatever. But it's exact enough for now. I'm powering it up. Also you see that I wetted the sponge. This has the benefit that the sponge is now much bigger, and I can get rid of the tin on the sponge. For the quality of my soldering tin, it's really unfortunate that I only have this 1 millimeter almost pure tin wire right now, soldering stuff, solder, but I will get better solder iron. Also what you will need is a pair of tweezers. These are actually cosmetic tweezers, and I will not use them for this kind of work in later stages, but the tweezers I ordered are not here yet. So I will have to wait till this powers up and then I will go. But first I will mount this board somehow. So, which might not be safe enough yet. I use the second as well. So, now what I want to do is desolder the old voltage divider, and I don't think I will need this because there's really not a lot of solder on it, and will hopefully go off very easily. But if I do, I will use this to desolder as well. And here I have a new voltage divider. I'll put it here. And yeah, I'm grounded, I guess. I think I should be. There's no reason why I shouldn't be shouldn't be grounded. So now I will draw it out of it. So this is still a bit too much. So I want the right one. Think. Yes, I want the right one. Let's see. Okay. What is this? Am I hallucinating or something? I'm actually left-handed. So this is how it looks from above. You can see that I can see the board quite clearly, and it amplifies the tip. So I think I will not try soldering with the camera in one hand because this will not work. So see you later when I have removed this part. So now it should be desoldered and I can take it off. Oh yeah, I destroyed it a bit, I guess. No, I'm not sure. Oh, this is just solid tint. No, didn't destroy it. Unfortunately, I don't have anything to clean off the solder residue here. I will probably put it away, not to confuse it with this one. Yeah. So what I will do now is I will pre-tin this set, and I will try to I will just use this thing for now, and I will take away the solder. Let's see if it works or how it works. Let's see if you can watch me do it. Oh yeah, the tin is melting. Nice, and it's gone. And it's gone. This works better than expected, actually. And gone. Ah, no, there's some. Yeah, there's probably some left for all of them. But it's not that bad. The left one is quite flooded still. Well, but it doesn't matter. So for now, enough of that vacuum pump, which is actually quite a nice tool. I like it a lot. So now let's go to pre-tin this. Take out some of the wire and preheat the plates. So now there's quite a lot of tin left actually on this plane. So I got a blob of solder on my iron. I didn't want that, so I cleaned it off, and now I'm getting some more solder over here. Okay, this might be a bit too much. Yeah, I have to clean this off as well. Stupid tin, seriously. So now I will have to put it in the ship in place. I hope you're still following. Let's get you a bit closer and take your iron and get started. This is quite a bad setup. I have to change this, and I just heat up. This is not good. So this is not really good. So this works, I guess. Oh no. Now it worked. Surface mount soldering is quite difficult actually, and you shouldn't start out with it. It's just that I had no choice in the matter this time, because I wanted to repair this device. Yeah, this doesn't want at all. I will have to put some more tin on it. Now I think that bonded. Yeah. Yeah, it. So let's add some tin here. Yeah, it's not quite taking to it, which isn't good. Let's try. No. Okay, this is just not good enough. So this is actually not even good for me. So I took off this blob. You can't work with it. Yeah, this is quite the difficult task. So, at least that one bonded well. I have to get rid of this blob again. And yeah, where's my pump? Can't have it like this. And now it looks good. I think, I'm not sure. Let's have a look. Yeah, this looks okay. Now we have a 2. This is such a hard task actually for a beginner. I do really not recommend it. Now I got that one going. Very nice. And come on. Go in there. Not quite yet. Yes. Now, so let's have a look at it. So the ones I soldered last are actually quite dull, and I don't think they are good joints, but I'm not too sure. I either have a choice to try it again and put some more solder in it, or just try out the device. I'll probably go for the first variant and put some more solder in, and then I will try out the device. Now, these are some of the worst solder joints I've ever seen, but I can't help it since it's so small and I only have this huge solder stuff, and it's always, you can see how big it is in comparison to the ship. So I really can't get it in there quite as I wanted. And I tried the desoldering pump sometimes, but you see this is actually really not good. It's always too much, but I will try it anyway now. So let's see. So for testing purposes of the board, I have my GU base 600 milliampere power supply, which is actually brand new. I just got it, and I will have to see which plug fits, and then I will probably use 7 volts degree. You can choose what kind of voltage you want on the power supply, and this board supports from 6 to 20 volts, I think, and I will just go with the 7 volts because it's enough and it won't damage too much. So yeah, let's see how this works out. There's only 7.5, but that's fine too. It's quite hard to move. Let's just use this. So now we have a 7.0 volts power supply, which this is also from a mailbag, which I didn't show. So don't wonder. There's also some USB plug power supply, so I can use it as a USB power supply, which is nice. And oh, this is actually, here's a key to change this. The more you know. And all of them look the same, so okay. They have different holes, I think. So let's see what it's written on it. Okay, that's quite hard to take out. They have different things written on them. So we now have to figure out what kind of plug we want to use. The G, the N, the D, or the F plug. Because these, the other ones won't fit, obviously. So the G one fits. So does the D one actually. And the F one as well. And let me guess, the N one. At least that one doesn't fit. That's quite nice. So I will have to do some research, and I'll see you when I know which plug I'll use. Come on. Well, welcome back, guys. I couldn't find any information on the internet about this, so I just use the E plug. Oh, it wasn't an F, it was an E. And I guess you have to put it this way around. Where's an arrow? Where's an arrow? There's also an arrow. This is not really... Okay. So... okay, you can see here, if I put it like this, then on the outside I have minus and on the inside I have plus. And if I put it like this, I have minus on the inside and plus on the outside. So I will have to check again with the standard to be sure how the polarity has to be, and then we'll connect it to the power and just see how it works out for us. So see you in. So guys, I found on the internet that there are several, there are two possibilities, and which doesn't help at all really. So we'll have to look at the board if we can find any way to see which one is the grounded state, so we can measure it with the multimeter which I have here, and we'll put it to the ohm measurement. Let's go for 2K because it won't have a lot of resistance. So if we have a loose circuit, it won't show us anything, and if we don't, it will probably show very low ohm reading. So these two are connected, the front one and the outer one. These are probably both ground. And we have the resistance of, okay, yeah, it's okay. Yeah, about 1 ohm. But I can't, or even less, I'm not sure. There's quite like no resistance at all. And we can see if this is also connected to like some other places, like here. Yes. So we now know this thing goes to ground, so it's the minus basically. But we don't know which plane it is. So if we look into it, it looks like this jack here is, this thing is connected to the out part, so in the middle, this one is in the middle, and this is the plus part, so there's power in the middle and ground outside. So we'll configure our plug to be the same. we have two symbols here, and this one has ground in the middle and power on the outside, and this one is ground on the outside, power in the middle. This is the side we want. So we are connected like this. Oh, this is very... okay, now I got it. So I will put it into the power. And it's in. So for safety measure, let's measure it again with the voltmeter. We're expecting 220 volts. So in the middle we have plus, so we we are actually expecting 7 volts, so let's not confuse things here. Put the red probe in the middle and the black probe on the outside, and I get a positive reading, so that means it's correctly plugged in, because if I had ground in the middle and power on the outside, this reading would be positive, but it's actually negative. So you can see it's minus 755, but with the correct setup it reads a positive measure of 7.56 volts. So we're good to go with this. So we will plug it in now, and we will see on the left side we have 3.3 volts enabled, and on the right side we have 5 volts enabled with the jumpers, and I will see if that's correct. So first thing I hope will happen is that the LED lights up, and it doesn't. It could be broken or something, I'm not sure. Okay, I put the power on, and let's see. Yeah, it doesn't heat up anywhere, so that is fixed. Let's measure the outputs. On this side, oh, this is actually quite annoying. How do I do this? So we got I reversed this. So this is problematic because I actually get a reading of 6.8 volts. As you can see now, hopefully now. Come on. It's hard to do with camera, but you can see it's 6.8 volts. So I might have to change the 5 volt regulator as well. Let's check the negative, the 3.3 volts output, and it measures, oh very nice, it measures 3.3 volts, just like we wanted to. Well, okay, now it does. So this means we will have to replace the 5 volt regulator as well, I guess. Now let's do it. Take the board off from the power supply, even take off this thing and mount the board again. So we will again power up our soldering iron. Yeah, this is quite annoying actually. I had hoped that only the 3 volts regulator was destroyed. The iron is heating up, and I'll see you when I start soldering. While this is still heating up, I Forgot to mention that you should have something like a jar or anything for trash. I just took this one where I usually collect parts, but this time you see the voltage regulator from before and some tin, because once you sucked the solder from this thing, the next time you push down, it drops the solder down. There's some, maybe you can see it, there comes some stick out of it which pulls down pushes down the solder, and this way it doesn't stay in the syringe, and it's quite nice. So, but you shouldn't get it all over your place, especially if it's leaded. And yeah, it doesn't matter actually. Just get it into a jar, something to keep your workplace clean. And I think with this we come to. This is still quite cold. So let's still wait a bit. So I'm back and we'll have to start over again. This time with the left one. I think I will not film it because you've seen me do it before. Oh, and I forgot my tweezers. Oh, actually I can start without them. But we'll get them soon enough. So I'm done with the soldering. It is actually even worse than the first solder job, and I'm not sure if I desoldered a part here. It's quite easy to do it with a syringe, because when you press the button it just shocks the board, and I might have hit something here, but if I did I couldn't find it, which is quite unfortunate. I hope I didn't do it, so I'll have to test the board. I hope it's just a capacitor which is to save the circuit from being destroyed, but I couldn't say anymore. It's gone or never existed. Now the uncertainty is eating away at me, but I can't help it now. Maybe I will look at video footage later. So, back to testing. So, I'll take the board again into the power supply. And now watch what happens. Not much. And so far it's not getting hot. That seems to be good. So this is the 5 volt, this is 3.3 volts. I will just measure them both again. And let's do it. Actually, put this here so you can see it as well. So what did we have here? This is the 3.3 volt, still intact. And the 5 volt seems to work as well now. So that's quite nice, and I really don't know if I got rid of some part here. So I will test for both sides the 3.3 volts and 5 volt connections. So I have to change this over. So now here, this should be the 5.5 volt connection. 3.3 volt exactly, and this is the 5.5 volt. So there you have it. Repaired board where I fried my voltage dividers, and even though my solder job is really bad, as you can see, it still works. And even I might have destroyed some capacitor to save circuits, but I'm not sure about that. really, there should have been something. I will look into it again. But apart from that, I have a working power supply again. Quite happy with it. So I hope you will watch my next video again. See you then. Bye.